Alrighty. Hey chat, how's it going? Sorry for the delay today, I was tired. So I slept in a little bit. Or I didn't really sleep in. I got home, got changed, took a nap. You know, the things you do when you're just tired after a day of work. But hey, I'm good now. I got some cool stuff to show you guys. So over the weekend, I ran off some additional prints. So I printed more fan ducts with the Positini. Additionally, I tested a side wall that had some as well. So like you could take it off your tool head and put it on the side wall as like a little storage. I just realized I have not, and I don't. This is gonna be a fairly short stream. I'm not gonna blast this on everything. Oh, that one fell. 1 second. Okay. Yeah, this is the one. So like, this is your thing, and that's holding, and then you can just slot this on to other parts of the printer. So we're gonna continue developing this. I'm really happy with how this mount has turned out. It is very easy to remove and to install, and it there's no wobble. There's no there is a, if you obviously if you crank it, it's gonna bend a bit. It's plastic, but for what the printer will be doing, nothing. This is a solid mount, and it's so easy to remove when your tolerances are tuned. I need more people to test this. That's my current problem. I need more people to test this with their printers to see if this is replicable. I can replicate it on my Bamboo X1 and on my Prusa Mark IV. So, I mean, and those are obviously high quality machines. I have a SVO8 that I'm going to try to replicate them on. Um, but the only other machines I have is a Rook, which that'd be a great example for a machine that's not tuned because it's not tuned, or uh, what else? Or a Positron. But like this is supposed to be made out of like ABS ASA, so you're gonna probably use a machine that's higher quality. Um, so I just need more people to test this. Speaking of work, you work in cybersecurity. If I'm not wrong, you did see a thing about Apple offering to anyone that hacked their new eye. I did not see that. I don't really work in cybersecurity. I am cybersecurity adjacent. So I work in an MSP. What that means is managed service provider. So we manage all of the IT systems for any given client, and we have many of those clients. So we're essentially outsourced IT. So like if you have a like for example, if you have a business with 10 employees, but you don't want to hire a dedicated IT guy, because that could cost like upwards of 60 to 80 grand a year, depending on the skill set you want. What you can do is you can pay like 40 grand a year or 50 grand a year, and then you get access to an MSP and all of its resources. And what that does is you don't have to pay like 100 grand for a top tier engineer because the MSP already has that. You just pay the base rate, and then you get access to their variety of technicians, as well as all their tools, documentation, etc. So I work at MSP. I'm a project manager as well as just service desk individual. So yeah, that's what I do. That is pretty neat. I am interested to see what comes of that. Uh, yeah. Hey Betsy, welcome. How's it going, Betsy? Have you seen Positini? Our Picatinny rails for Positron? I think you were here last stream. It's kind of cool. We're gonna be continuing that. What I want to do is I want to design a version of this that doesn't have to get removed, and could stay on. I've had a lot of feedback like, oh, I don't want to be removing this. And I'm like, okay, I'll design one that doesn't. So we're going to design another version of the arm that does not have to be removed. And that should be easy because it's just moving the probe back. I can just like split the two parts, shift them, etc. Anyway, so we're going to make one that's moved back to a safe distance. And yeah. One that's moved back to a safe distance, you could use the actual Positron rail to dock it further back for like storage and stuff. Anyway, I'm rambling a bit. Let's pull up the CAD. So we had Chris's basement. He was thanking us for including pre-made supports. So I want to take a second here to show you guys how you do that. Oh, I got some problems. 1 second. Okay, so that's just fun. Can I just delete that? And delete that. Yeah, that works. There we go. Okay, so when you're making a model like this, one thing that's important is to be building in like 0.4 increments. I don't know if I've done that here. I just realized that. 1 second. Alright, do this. Yeah, roughly. Or sorry, 0.2 millimeter increments, because that's your layer line height. So in order to get a good support in there, what you want is this gray piece is your support. That's the part that does not actually come in contact with the piece at all. So you want to maintain, distance. So for like parts you don't want to stick at all, 0.4 to 0.8, that's a good distance that you want. For the parts that you want to act as support, you have it one layer away, 0.2. So that's what we did here. And when this prints, you just break off that piece right there. Just comes off cleanly. And then that's it. And if you do this for any parts that you design, trust me, you're going to make people so much happier. Because it makes printing overhangs so much easier. There are some parts on the Positron I need to add included supports, like the actual part I'm holding right here. Though, actually, it looks like it did... No, actually. I was thinking we should put one for this piece here, but actually I'm looking at this, it printed just fine. So, never mind, we don't need to do that. Okay. Additionally, over the weekend, I made example. Hi, Tech Jeeper. Welcome. I made an example kind of slide. So I formalized the current standard for the Positron. So it's going to be measured by 1 by blank, which is X by Y. Pretty standard. So from left to right here, it's 1 by 2, 2 by 2, 4 by 2, and then 1 by 4, and then 1 by 2. So obviously, right now I put all these here so like you can just kind of copy them and like iterate upon these. We will make a... Hey Joseph, welcome. We will make a parametric design of this at some point, based off of these measurements. But yeah, this is pretty cool. I'm new to parametric design, so I'm going to mess up. I'm gonna make a mistake at some point. But this is gonna be cool, it's gonna be fun, and we're gonna do it together. Betsy wants to know, AMD or NVIDIA? I'm leaning towards AMD CPUs and NVIDIA graphics cards. I just like NVIDIA when it comes to graphics cards. Okay, let me actually give the reason why I like NVIDIA. So they haven't done this recently, but they kind of won me over when I was younger. It was the 900 gen? Or was it the... No, it was the 600, GTX 660. I believe. Yes, 660. So GTX 660, what they had been doing for a period of time is they were putting an encoder chip on all their graphics cards, and they weren't telling anybody about this encoder chip at all. And then they just were like, oh yeah, by the way, this new app, NVIDIA GeForce, will let you save up to like the past 30 seconds of gameplay because of this chip on your graphics card. And everyone's like, what? They retroactively added a ton of value to a bunch of older cards because they decided to add this chip before they had the software ready. I think that's cool. What NVIDIA has done software side is really impressive. And like, for example, I'm right now, for my background, I'm using NVIDIA Broadcast. That's awesome. It works. This is literally the perfect green screen. Sure, it glitches out sometimes, but like, I don't need a green screen. It's great. I always feel like AMD is trying to play catch up when it comes to software. Because like NVIDIA will release something like this, and then AMD will make something a few months later. But when it comes to CPUs, AMD is killing it. Yeah, well, they're still focused on software. I think that's the key point. It's not that they don't care about the gamers. They are focused on the software, and that's kind of what they've always been. Like, they've always put a lot of effort into software because that's what sells, is good software. Great hardware is good as well, but honestly, it's the software experience, how you can incorporate it into games, how you can incorporate it into just like workflows, etc. So software is important. They've always focused on software, and right now AI is the biggest thing in software. So take it for what you will. Let's be real. Graphics card companies don't care about gamers. Neither do CPU companies. They don't care. They don't. If they cared, then they would have like actually done something about all the GPU mining and all that. But no, they were making bank. They didn't care. I have not seen Adrenaline at all. I will say, my Steam Deck has absolutely convinced me that AMD GPUs are good. I just prefer NVIDIA. And that's mostly because a lot of my workflow and a lot of the software I use uses CUDA. And uses CUDA really well. And I can't do that on an AMD, so. My workflow requires the Team Green. Yeah, buying an NVIDIA card during the pandemic was hell. So, okay, this here was my attempt at starting to make a parametric design. So this is currently how you can add a Positron rail to a model that you make. You just take this model, slap it on there, merge it in. So if we come back to the side rail here, and if we look at the CAD, you'll notice if I take away these two models, I literally just brought that model in and just started shaping it into the model. So, yeah. If you only know basic CAD, that's not that difficult to do. Yo, we're only 5 away from 500. Hey guys, make sure to share the stream with your friends. Let's get to 500 subs in YouTube. That's gonna unlock a ton of stuff for us. How about a 500 giveaway? Maybe. I'll talk to some people about that. I am going to go see KB3D this weekend. Maybe they'll be willing to sponsor something. Who knows? But let's be real though. In terms of 3D printing streamers, 500 is not a lot. Anyway. So this is our test print piece for people to actually test Positron rails. This way, so you can just print the whole thing and have it in the right orientation. It is designed to print like this, in this orientation. It's just how I designed it. It prints well in this orientation, and the real reason is because layer line strength. If you print it in any other orientation, these peg holes have a higher chance of breaking. And so we don't want that. So it is important that the pegs and the actual slots are printed in this orientation. Actually, this reminds me. We need to actually redesign this. So this is a test piece that you can print to test to see if your printer can do Positron. It works well, but the included support is like completely just fused. So let's see here. I think what I'm gonna do. How do I want to do this? Let's do this. Let's try. We're just gonna do an offset. Okay, there we go. Finish sketch. And we're just going to shim off another 0.1 mil. Just like that. That should be good enough. I'm not confident. All right, actually, hold on. Let's do this. Let's delete this. Or not. Let's not delete that. Okay. It did not like that. Here, this is what we'll do instead. So we're going to just follow this curve here. Oop, nope. Alright, and then there. Oh, goddamn. I keep forgetting how a 3-point arc works. Nope, that's not what I want either. Where's the arc that, like... Is it tangential arc? This doesn't feel right. Wait, yeah, hold on, that didn't feel right. Yeah, the gray piece is just a support system. Now I need to find a nozzle camera for the rail system. Yeah? I mean... Yeah? Oh, is it conic curve? Hold on. Yeah, there we go. Actually, what am I doing? I don't need this to be that precise. Just need go there. There. And then I will use a fillet to make it look better. There we go. Now that should be easier to support. Okay. Now what we do is we just do this, offset that. Oh, why is it not letting me offset it? Okay, hold on. project. Offset. Negative 0.3. Like that, and then put that here. Something's not connecting because this is not creating a face. It's right there. That's close enough. Oh, my computer really doesn't like this. I mean, yeah, why not? Doesn't hurt to be fancy. This is probably not going to work, because you really shouldn't chamfer your supports, but, like, I want this to look fancy. Alright, let's go ahead and export this and give it a try. Positron test sled. Let's load up Orca. And let's send this off to the Prusa. It should be a quick print. Okay, so here's the next important part when it comes to pre-included supports. You want to go to Slice, and then you want to actually check here. So, like, I'm not super confident about that. Let's see. So... part of me wants to... Idea. I'm just going to do this in 2 spots. Essentially like 1 layer thick. Well, let's actually do this. If we want it 1 layer thick, we need it right here, 0.2. Alright, and we want this to be, we're going to do 0.4. Go to the other side. We're going to project that. There we go. And then we're going to do it again right about here. So I'm doing something I shouldn't be. And that is, I'm just kind of doing this randomly. Normally, again, you should be doing this at set intervals. So, like, exactly 0.2 millimeters. I'm just kind of throwing this in here and seeing how it's going to work, and then kind of just praying that it does. So, let's re-export this. What's the magic I did to bring the sketch to the opposite? Okay, so in Fusion, all right. So in Fusion, if you click on a surface like this and you hit create sketch, it's going to create a sketch of the surface that you selected, but it's not going to bring in, like if I do a line tool, it's not going to snap to any other geometry on any other bodies, including other parts of the same face or of the same body. So what you can do is if you hit P for projection, you can then select another face. And if you hit OK, this is while in sketch mode, it will bring in all of the point references of that face to the plane you're working on. Here's an example where it is super useful. So if we go right here, you see this angled plane? This is a pain in the ass to work on because it's angled. Okay, but say we want to do something where it matches up with this here. If we hit project and we select that, then what you'll notice is on the actual 2D plane of this face right here, it actually has the shape of that piece projected onto the plane. Really useful. Madeline taught me that. And I'm very glad she did. Did I already export that? Let's check. Yes, it did. Alright, so now, in our slicer here, you can see that we added these two little supports. And if we slice the plate, perfect. Now you'll notice, if we slice the plate, that at layer 4 here, it connects. So that adds a little bit of structural support for the rest. And then at layer 18, it connects again. And there we go. Now, when I go to remove this, those should just snap right off and you go on your way. Yeah, they're meant to be like really thin little pieces of filament. Those might be too thin. We'll see. In fact, I'm starting to question whether or not... You know what? I want to try something. If I have really good first layer adhesion, I probably don't actually need included supports. Let's see that. Okay, so we will do this, arrange objects, and then we'll go to other. And to see if this actually works, what we'll do is we're going to do print sequence by object, and then tell it to reorganize again. There we go. Slice plate. So which one's first? Okay, cool. So let's see which one actually works. I don't think this second one's going to print correctly. I think it's going to fall off because the amount of surface area it has is like nothing. And here's the fun part. We can't actually... hold on. Let me add one more and just do like built-in supports. Let me give things a fair chance here. Okay. So support, enable supports. We're gonna go with normal supports. Yep. Just standard normal, and we'll go snug. Alright, yeah, we'll see how all those work. And we'll see what's the best results. If my included supports are the best, if generated supports are the best, or if it can actually work with no supports. So let's go ahead and send that off. That's just going to take 35 minutes, but, you know, I'll go check it later. Okay. There we go. We will see how that turns out. Hopefully it turns out really well, because that'd be great. Just checking my stuff here. Got a couple Discord messages gotta look at. All right. So let's look at this. So let's... Okay. This is what we're going to do. So we've had requests to design this so that it could kind of actually stay on the toolhead. I am not a fan of that, but I will not deny people that ability. I think it's only fair that I, you know, take a request and, you know, actually fulfill it. I think that is fair. So I'm thinking a position right there is good. So we're going to go ahead and fill in all this text, because this will not be something you have to remove before printing. Actually, before I continue, let me go ahead and save as. Well, no, I have the MicroProbe Positron mount right here. Is this the latest version? It is the latest version. Okay, so I will leave this as it is, and then we're gonna derive the mod from here. Have I mentioned that I don't do things correctly? Normally, when you're working in an assembly like this, you would have like a master. Callie, hello. I hear you. Shush. Capture position. And it's gone. Cool. That's gonna make this next part easier. All right, so we want to split the body. How do I do this? Essentially, that line right there is where I want to split it. Nope. Okay, I think I see how I have to do this. Do whatever you want. I'm not your dad. So we're just going to Go right here. I'm going to make this microscopic. So small that it shouldn't come up in a print, but we'll see. So 0.05. So it's big enough to appear on our CAD here. There we go. Actually, wait, what am I doing? I could have just done that as a new body. There we go, new body. Now I can delete it when I'm done. Okay, split. Nope, nope, nope. Just one body. Thank you. Okay, that did not work. I apparently have to do it as part of the body. Okay, let's try this again. Split. Uh-huh. There we go. Actually... let's project this face onto the other side. Because I want to account for that as well. Because I want to do as little changes to the geometry as possible. And the only way I'm going to do that is if I don't cut off any of our fancy fillets. 0.05. Finish sketch. Okay, there we go. Split body, splitting tools, and we're going to go right here. Split. Cool. Now I can go in here and chop off that bit. There we go. Back to normal. But now, let's see. That back. Just like that. Alright, so the next thing, so with this design, we're gonna need something to hold the wire. Fancy fillet is the official cat food of the Positron 3D project. Yep, you're pretty much right. Alright, so we're gonna cut this back. Oh, too far. Just right there. Right, that gives us plenty of room to work with. Okay. So let's go ahead and project. Cool. Now we can work with this. So what I like to do is I like to just use straight lines in my design, and then I use fillets to kind of smooth things out. So let's see here. Go. I also like to be somewhat symmetrical. Oh, that came out perfect right there. Well, actually, you know what? Hold on. I need to see something, because for this to work, that cable has to clear this line. And it does. Cool. Okay. So that works. That does work. I think... Okay. All right. Now we drop that down. Yes, hello, Callie. I'm right here. There we go. First, we're going to play these. Yeah, right there. And we'll do another one right here. Whoa, hello. That escalated quickly. Alright, we will do one there, but it has to be really thin. There we go. Not entirely convinced on that shape, but I mean, it works. Now let's change that up a tiny bit. Alright, let's try that. There we go. I feel like that is going to end up looking just a bit better. Wait, what? Why is that not? Just delete that. Try again. Oh, I see why. Yeah, that would do it. Okay. So I need to break that up a little bit here. Go. No, stop. Can you not grab that, please? Oh, target chain. There we go. What? Why are you not letting me chamfer, dude? Well. Why? That's really weird. I don't know why it's not letting me chamfer. Okay, let's just try on the inside. That one worked. No problem. At all. No, no, no. Oh, no, that's not what we want. Okay, let's try that. Maybe it's being caused by that. No, why? What I really hate about Fusion sometimes, it doesn't. It tells you what's going on. It doesn't show you. So something's preventing me from doing a fillet here. I think I know why. So okay. All right, so it's about 1 meter or 1 millimeter, not 1 meter. Oh, Jesus Christ, dogs, stop. All right. Create a conic curve, please. So conic curve again. There and there. there. Cool. Oh, it worked. Cool. Didn't think that would work. Then put a fillet here. Oh, that is not working the way I want it to. This is me chasing zeros. I should not be doing this. Damn, do I want this to look good. No one's ever even gonna notice that slight change I did. Literally just did that for nothing. Just glad I can now actually do what I wanted to do. Let's delete that. Oh, hello. You don't look very friendly. Can I just delete you? Yes. Okay. You don't want me to do this. Why don't you want me to do this? Oh, you have more broken geometry. I see. There we go. Will you let me do it now? Yes. Okay, we've got more broken stuff here. Oh, how do I fix this? I think the easiest way is to just cut off that sliver. I'm cutting the tiniest bit of material off of this, which is just hilarious. There we go. Now, if I smooth that out, there we go. Now I'll just do that again, just to make sure that's smoothed. Oh god, too much. Okay. The things I do for this geometry. 0.5. Wonderful. All right, let's try printing that. Good evening, Mr. Nomad. How's the filament faithful today? Doing good, Reverend. Welcome to the chat. Hope you're doing well today. Okay. Calling this the further probe. Because it's further away. Yeah, aren't I creative? Really, what are you doing? My dog's like jumping through boxes. All right. Let's orient this part. There we go. That looks good. Yeah, I know there's little details that I'm working on, like like I cut off a sliver there. Like, they don't matter. Let's be real. They don't matter because they are so imperceptibly small. It's not going to change anything. But for me, I have to. I have to make sure that it looks good. My brain just needs it. And that looks good. I like this. Okay. Let me get a screenshot of this real quick and send it off to someone that requested it. Who's this person? Oh, I guess I'll figure out another time. Okay, one conundrum. Let's figure out how we solve this. So with this one, we want the wire to be held, since this is possibly something that people will use while the printer is on. So let's see here. I need a flat surface to work on, which I've kind of cursed myself here. Okay, first off, let's isolate this component. Okay. So I'm literally thinking just like a little hook that goes right here. Something small that will capture the wire. and hold it out of the way. So I'm thinking like about right there. That's about as flat as I'm gonna get it. Oh no, it did not like that. Okay. Does not like that face. It's not flat enough. Alright, that's fine. I could just use this face over here. Then just project this. Give that a minute to think. Okay, there we go. Let's see, how do I want to do this? So clips are tricky because it kind of relies on an overhang. So I think I'm going to do this slightly differently than what you might expect. Or this might be what you expect. I don't know. We'll find out. All right, so I'm just going to kind of do this. Yeah, I'm just thinking like that. Oh, that's too steep. I think of this upside down. Okay, there we go. That makes it a lot easier to plan this out. So can't be steeper than a 45. So this would probably work. And then do an offset. Actually, that's too steep. That's not going to work. This doesn't even look like it's going to hold the freaking cable. This is why this is so hard. It's like, I can't anticipate how people are going to use this. And this thing kind of requires you to think about how people are going to use it, and that's hard. Okay, hold on. So if I do it from here... Oh, God. Okay, I know what I'm gonna do. Okay, so putting something in here is not gonna work. What will work is putting a spot in for a zip tie. That's easy to do. So what we do, we'll do it right here. This is a perfect spot for us to put a zip tie. So we're gonna go here. And with how this will work, this will come out perfectly. So what we're gonna do is we're gonna just go in the center point here. put down one of those. Then we're gonna put another. Right there. Okay. And 0.4. Okay. So now we do revolve. Well, that didn't work the way I thought it would. Let's try this again. Oh wait, hold on a second. I see why. There we go. Revolve you and you along that line. Boom. I just gotta figure out how to put a thing in there. Oh, let's isolate this again, because I forgot to redo that. Okay. So this will work. I just gotta put like a little stick in here. But this would work. How large even is that? That is not big enough. Okay, so let's do this again. Let me get rid of this tiny sliver of a face here. Oh, right, I need to get out of the sketch to do that. Oh god, the model doesn't like that. Is there like a bunch of little faces in here? No, my model just does not like me doing what I was trying to do there. Okay. Well, let's see here. We just need it to be like right here, and that would work perfect. So actually, I can't put, okay. All right, we're just gonna do it in the middle. It's gonna be decent size so that it could be a decent size zip tie. This way, we're not really limited by other factors. Alright, so we're just gonna make this straight up, like, yeah, that big. And then that's a 5mm overhang. printer should be able to do a 5 mil overhang, right? That's a standard overhang, right? That's not crazy. Hey, Michael, welcome. This is we're working on the microprobe. Someone asked, we got multiple requests of making a mount that is permanent. I'm not a fan of a permanent, but I figured it wouldn't hurt to just do it. Alright, there we go. Now people have a spot for zip ties. Yeah, 5 mil overhang should work just fine. I don't see a problem in that. And then people can tie the probe sensor to the actual arm here. Can't use an eddy sensor on the glass bed. That's the one downside. And the new PCB bed, because it doesn't, as far as I'm aware, because it doesn't use a sticker, I don't think it can use an eddy sensor either. Because it uses a bunch of smaller magnets. I think the eddy sensor relies on there being like a sticker magnet. I could be wrong. It could just be sensing like the yeah, I don't know. We're looking into a bunch of other options. Big Tree Tech sent us a ton of microprobes to experiment with, so that's what I'm running with right now. But yeah, right now this is what we have. We have this one, and let me actually pull in the other one that we have. 1 second. All right. Here is the other one that we made. Okay. So let me show you the difference between these real quick. And let me make sure I hide the sketches because there's a lot of sketches on that. Okay. So we got 2 mounts here. One is meant to be a temporary one. So that is this. So this one's meant to be temporary. It gets really, and I mean really close to the nozzle. The probe is literally like touching the silicon. This is meant to be, you want the most accurate bed probe, that's the most accurate bed probe. But you have to remove it before you print, otherwise you will melt your probe. But some people are like, oh, but I want to keep it on. And I'm like, that's kind of dumb. Hear me out. It's a probe. You're not going to use this ABL probe every time you print. Ever. You're going to use it once when you unfold the printer. That's the only time you're going to use it. Unless you plan on turning your bed into a taco mid-print, you're never gonna use the ABL sensor after you deploy the printer. This now sticks out too far from the tool head, and it can be broken if you try and fold the printer with this attached. But, you know, people want a permanently attached probe. So you know what? They're gonna find, maybe they'll find out how this just breaks on their tool heads. Who knows? Maybe we'll see. Give me a second. Our Prusa just finished some test pieces. Let me go grab those real quick. All right, great news. Generator support worked perfect, but the included support on this test piece also worked perfectly. That just broke right off, but I actually kept the piece. The part that we printed that did not have supports on it, yeah, that just fell off. So that did not work at all. How does this go? Just like this. Okay. So let's see if that worked. Yep, that works great as a test piece. Oh wow, that works perfectly as a test piece. Yeah, that's perfect. I'm gonna have to upload that, and that is a perfect test piece. The idea is that it gives you enough leverage to push it off, and this also helps you kind of work in the rail slots. So it just clips in, pops out, and this helps you confirm with the smallest amount of filament whether or not your tolerances on your printer are good enough for Positron. Now again, the standard for Positron is not final yet, because again, no one else has tested whether or not Positron can work on their printers. I keep asking people, hey, can you try printing this? And no one has. I know it works well on a Bamboo and on a Prusa, but I want to make sure other people can print this, because this is a very demanding piece. But yeah, that works great. Absolutely no complaints. Pretty sure I'm doing it upside down though. Oh yeah, totally am. But even right way up, that just works. It's addicting too. Like, if you print one of these, you're gonna be fidgeting with it because it clicks in so nicely. It's in the Discord, man. Let me upload the new sled test. Let me do that. Yeah, if you go into Positron forums and you go to the Positron mods, it's there. It's Positron. I need to update the test sled because that worked great. Okay. Positron test sled. Okay. There we go. Really happy with how that turned out. That was perfect. Okay, back to this. Let's go ahead and export that model. And we'll send this off to the Prusa. Oh wait, did I already start printing this on? Oh, I did. Before I finalized it, I did. Whoopsies. I forgot I started printing that on, I totally forgot I started printing that on the X1. Okay. Come on, Slicer. Slicer's frozen. Give me a second. Okay, there we go. No, wait, that's not it. What did I save that as? Oh, Mount Perm. That's what I saved that as. There it is. Hopefully that little thing... That's not going to be strong enough. 1 second. Let's go back to the CAD here. Yeah, now that I look at it, that is way too thin. Right? Yeah, that's only 0.8 mil. Yeah, I can afford some extra length to that. Okay, yeah, let's make this wider. Yeah, let's make it whole 1 mil. Sebas, hello, welcome. Alright, revolve around there. We are going to tell it to join. Can we go the other way? Okay, there we go. Leave that there. Yeah, we'll just do 180. And then... yeah, that's fine. I don't care if it's sloped. I kind of care if it's sloped, but I'm going to resist. I'm going to resist. I'm going to resist. Because it's not going to matter. Look how tiny. That is literally 0.07. The printer will not be... The geometry is not perfect. The geometry is not perfect, but I know the printer will not render it. Ah, I'm perfectionist. Yeah, we're still working on Positron. I did some more testing over the weekend. I am actually very happy with the current overall, I'm very happy with the current overall design and tolerances. At least with my printers. I still need people to test it. Shush, I know that part was sloped. I don't care. Couldn't be me. Trivial geometry. No one's ever gonna see it. Yeah, as I suspected, it doesn't even show up in the print. Like, it just does not care what happened there. Because it can't. Even if I put a 0.2 nozzle on there, it would not be able to render what we did. Anyway, so the reason you use spheres like that is because you can push the zip tie down and it will curve back up the other side. So that just makes things nicer. Okay. Put this on the Mark IV. Oh, that's a 0.6 nozzle. Hold on. 0.4. Transfer. There we go. Send it. I'd do all the testing you want if I had the rest of the positron to put the parts to work. Right? That's only 99% good. Unacceptable. Listen. I'm trying here. I am trying. I can call you when I'm 20-something daisies. Like, I haven't even tested whether or not the screw... Like, I designed these two mounts. I haven't even tested whether or not that hole diameter is good for an M2. Like, that is a 1.8 diameter hole, so it should force M2s to thread. But I just threw out that number. I haven't actually tested if an M2 is going to go well into that bore. So we'll find out. But yeah, there you go. So for people that wanted one that could be permanently mounted and not melt when next to the hot end, there you go. This won't melt next to the hot end. I hope everyone's happy. This is not what I wanted to work on today. But it sounds like the bamboo just finished. Let's go grab that part and check it out. We are going to test mount it to... You usually do 1.7 for M2? Okay, then cool. Then I picked a good size. Okay, this printed really well. Let me put a light on it. Is it showing up? No. My thing really wants to just throw my out. Okay. It looks good. It looks really good. Oh, Tech Cheaper, thank you for the shout out on Blue Sky. Appreciate that. Ladies and gentlemen, if you want to keep up to date on just like what we do in general and like when I may or may not be streaming, I am on both Twitter and Blue Sky at Nomads Galaxy on both. And if we ever have a delay like today, I use it. Hey, Maker Viking, welcome. How's it going, friend? Oh, okay, I have to admit, that did turn out really good. Hate to admit it, it did turn out really good. And that clips right in. Oh, it's butter. Oh my god, it's flush. Two printed parts that are meant to mesh together are flush. Wait, what? We hit 500? What? Did I just hit 500 subs and my thing has not been telling me that I've gotten new subs today? Is that really happening right now? Come on, Streamlabs, you're supposed to be alerting me when I get subscribers. Holy shit. Everybody, thank you for subscribing. Okay, well now it works. What? Hold up, what? Thank you, Joshu. I do really appreciate that. We have now made it... We've made our goal of 500 subs. So, if you want to know what that means, that does mean actually a good deal. Here, let me actually show you... Can I show you this? I don't know if I can show you this. Let me show... Well, we do appreciate your OCD. We appreciate it greatly. If you enjoy CAD streams like this, where we're tinkering and designing stuff for printers, I'm starting to do these more because I'm at a point where it's like I don't have too many printers to build, but I have a lot of improvements to design. So let me just check. Sorry, I saw something in the background. Where am I? My YouTube studio. Here we go. Thank you guys. Seriously, thank you so much. So, the reason our goal for 500 was so that we could get monetized. Because right now we're not monetized on YouTube. We're monetized on Twitch, which is why we dual stream. But yeah, we haven't been monetized on YouTube. With 500 subs, we are now halfway to being monetized. What I mean by halfway is we have met the eligibility for the first two items. The first two items are like the easy items to hit, which is minimum 500 subs and 3 video uploads in the last 90 days. So, yeah. And then one of the following. Either 3,000 watch hours in the past 365 days, which we're halfway through. Thanks to all you, we have 1,400 watch hours. Or 3 million views on shorts. I'm never gonna make that. But anyway. So let me move to this other camera here. I will turn off my green screen. Oh, thanks. I need a larger West 3D shirt. This one's showing off my boobs. Alright. Let's turn this off for a moment. Ignore the trash. Yeah, check this out. That is a perfect flush. That is perfection. And there's like no wiggle at all. No give. And then, oh, it's on there tight. Just pops off. So again, pick where you need it. You push it in. Flush. Flush. Oh man. Oh, okay. Let's get that on a tool head. So here's our fan duct. Oh, that has a little bit of wobble. Is that just because that has been worn out? Let's try a different one. No, we got just like a little bit of wobble. Okay, so what we're going to want to do... Let me try one more time. The friction fit connection that we're using is Positron. It's a Piccadilly style connection that we came up with on Friday. And because it looks like a Piccadilly rail, we are jokingly calling it Positron. And we are sticking with that name, because I really like that name. Okay, so what we're going to do to remove this wobble... Oh. Okay. Sorry about that, guys. I really need to be monitoring my microphone so that I know when that happens, but I don't like to hear myself all too well. Anyway. So, on these pieces, this clips in. Man, I hope you can hear that, because just listen. Oh. Butter. Well, actually, no, crunchy, but it's like the good crunchy. It's like, ooh. It's like the cracking of bones, just... Oh, wait, this one tight. Mmm! It's... I love it! It's so addicting! Like, seriously! This is a fidget toy! This is just a fidget toy! It's just... Anyway, okay. So to remove the wobble that we're having here. So these are the same rail tolerances, but this one is just tighter. Let's try this. another print. Oh, that one's a little wobbly too. Okay. Oh. Drop that. Okay. So how do we remove wobble in Positron? Well, it's easy. We just add another dowel. It's easy in theory, but it's really annoying in practice. But here's the original mount. So this is the one that's like remove before flight. And then that just... Hear it? It's just... It's so small. But then this is really flush up against everything. So this doesn't have any wobble. So this one's a solid fit. But you have to remove this one before you print. Here is one of the sleds that we made. So this is one of the test pieces. So when you test the tolerances, you want to print out one of these. This one, which one's the one that had to include sports? I forget. They look the exact same. So you get your two pieces, the rail, and then your test sled. And then the sled goes in, you push down on it. Oh, make sure you line the actual things first. Oh, that's not going in. Oh, here we go. You ready? You ready? It's like Lego. Yeah, you shouldn't print on planes. Yeah, we need ankle grip attachment for extra tacticalness. Use embossed line on the inner and outer wall to stiffen it, maybe. So here's my idea. So what I did before, so the original ones that we have here, these only used 3 pegs, and these had just the littlest bit of wobble, like I can't even keep my hand, like just the littlest bit of wobble. Wasn't a fan of it. So in the next iteration, I just added another peg. So we went to 4 pegs. That removed it. So if I just add another peg to the round one, where did I put it that? So if I just add another peg to this, that should remove the wobble. Yeah, that's just annoying to have to work with. Yeah. There's always going to be some wobble since it's lever against the mount. Yeah, no, 100%. There's really no way, especially if I want it to slide in and out smoothly. Like this. That's a very smooth mount. There's not a lot of friction in there. Which is weird, because again, same tolerances. And on this piece, like, no wobble. What? No, there's some there. Again, it depends on your printer. This was printed on X1, and there's just that tiny bit of wobble. This was printed on the Mark IV, and let's remove the one sled piece, and it slides in beautifully, but no wobble. Like, that's perfectly flush. That is so perfectly flush. It's so beautiful. Yeah, the farther from the pegs, the more the wobble. Yeah, that's just leverage forces. It's normal. So let's... it's getting late. I started late, so that's on me. Go back to our live scene. Okay. All right. This is why I really need to make this a parametric design. And we will. I don't really know how to yet. I've never done parametric before. So anyway. What's the easiest way to do this? I could bring in a peg. Actually, yeah, that's going to be probably easiest. Pull in a sled example. Yeah. So we're just going to pull in the sleds. What? Where'd it go? What? Where? Okay, they're right there. What? Why? Why does it just disappear? What? What? Oh, I know why. There's... At one point earlier in the design on Friday, I threw up a sectional view, a cutaway view, and I just kind of left it there. So, okay. Here we are. So, I think what we're going to do is we're just going to use... Alright. So, we're going to hit OK. And then we're going to get the sled examples here. Bodies. We're going to do the 1x2, and we're going to move that up to component. Did that work? No. Okay, we got to unlink from parent. Break link, there we go. Alright, now that the link is broken. Move that 1.2 up to the component. Come on. Did it work? Did it work? Yes. Okay, cool. That worked. Alright, so now we take this 1.2. Let's see. Yep, that is correct orientation. So just select that, click assemble, and then we're just going to bring that over. Okay, hold on. I need to... How do I do this? Can I just delete that? Will it retain position? Oh, oh no. Oh, things are happening. Oh, it's computing things. Oh, that was a bad idea. Oh no. Oh god. Yeah, undo, please. Oh man. Okay, don't break that link. Jeez. Okay. That was a bad. All right. So I think what I'm just going to do, I'm going to move this back into the sled examples. Yep. And then I'm just going to delete the other examples. Cool. Now we'll assemble. Yep. Select that radial. There we go. And then do the same there. Boom. Okay. So fun when you work on large assemblies. Oh yeah. It's thrilling. Okay. So what happens if I delete that now? Cool. Okay. So what happens if I... Where did that go? Okay. What happens if I move that up? Oh, that worked. Perfect. Now I can delete sled examples. Yep. There we go. Perfect. That worked. Took a bit, but worked. Oh, wait. What? Wait. What? Oh, there's two of you. Alright, delete that one. Positron got a shout out on the most recent open hardware manufacturing podcast. Wait, really? Yo, send that in the Positron Discord. I need to check that out. Was it like a long segment or was it just like a short shout out? Because if that was like a considerable thing, that'd be awesome. Okay. God, I have to do this again. Yep, I do. I do. Oh, it don't like that. Okay, alternative idea. Let's try this before I dive into let's try this before I dive into trying to make a, what's it called? Let's try actually making these go further in. So technically, okay, that should work right there. So let me also do the profile on the other side. So a 0.2, that should put more pressure on this assembly. So if I'm right, without us having to add an additional peg, that should put enough like force on the pegs for it to that's awesome. I love that. That warms me heart. Okay. So putting pressure on the outer two should remove whatever wobble might be there. So hopefully this works. We'll find out. I'm gonna go for another 10 minutes here, guys. Because it is a work night. And in about 10 minutes, we'll be streaming for 2 hours, so. Okay, let's see if that little change, so if we actually look here, and if we zoom in on this part here. So I had previously intentionally left those kind of open, just for, I forget the reason why, but we're going to go ahead and close those up. And now if we slice it, yeah, it moved closer, definitely. I'm on strike. What's a work night? I don't know, man. I don't know. That, so if I actually look at the amount of wobble that we get with this piece, let's see. That tiny little bit might just be enough. No. Needs just a little bit more. So the problem is if I change this interface too much, then I change the way that the slide works. But I'm willing to try. That looks tight. That should be doable. That should be doable. I'm on forced vacation. What is a work? Oh, man. That doesn't sound like fun. Alright, reload from disk. Okay. That pretty much brings things flush. So let's see how that works. Okay. Well, there we go. So, typically how I do these streams is a lot of the large design process will happen during the stream. As you see, I did a lot of other work that was derivative of what we did on stream. So, yeah. Admittedly, Positron was not intended for large levers like this. It's really meant for stuff that's close. By law, You can only have 6 days, and you had 15. That's pretty good. Hey, at least you're getting paid for it. Okay. Yeah, so I designed this to just be close to the mount. And well, it's not close anymore. But oh my god, just that's worth it. Just it's so worth it. Just it's so good. Like seriously, just print out the sled test piece, then print out the rail test piece, and then you just have a fidget toy. Oh, jeez, if you don't drop it. And you just have a fidget toy here that just goes. It's too addicting. It is too addicting. Seriously, I've been fidgeting with these ever since we made them. Yeah. All right. Well, man, 500 subs. We made it, guys. That is amazing. I seriously can't believe we finally made it to 500 subs. For those that subscribed and we didn't get the notification, I'm sorry. I don't know who subscribed, but thank you for subscribing. I do sincerely appreciate that. Our next goal is to get 3,000 watch hours, which we will get if we just keep streaming. So the next subscriber goal is 1,000. So why is it 1,000? I will give you the answer. So monetization unlocks at 500. Being able to raid and be rated by other YouTubers is unlocked at 1,000. Oftentimes, when I stream on Wednesday or Friday, no, Wednesday, Grant from 3D Musketeers is usually streaming just before me. And, like, I mean ending, like, 30 minutes before. When he's streaming, I would typically hop on a little bit earlier so that people from his stream could just migrate over to mine. But he can't send his viewers over because I don't have 1,000 viewers or subscribers, which is stupid. It's just stupid, YouTube. It's stupid. How it should work is you can only raid other people at 1,000. I'm fine with that. Like, I'm fine with smaller streamers not being able to raid others because, you know, got to put in the work. But to not be able to receive raids, just that hurts the platform because one of the ways I was able to grow quickly on Twitch and actually become a partner as quickly as I did was because people raided. So yeah. All right, ladies and gents. I still don't know if we're going to stream on Friday. Because on Saturday I'm heading to KB3D, so I don't know. We'll find out. We might do a short no. We're not going to stream on Friday. I need to check with Pooch. As far as I'm aware, Pooch and I are still streaming on Wednesday. So I'll send a message and figure that out. But yeah, thank you all so much for tuning in tonight. I hope you all enjoyed yourselves. And hey, if you live in the United States, you have a civic duty. Please go out and vote. I don't care who for. Vote for whoever you believe in. And vote for whoever you believe is good for what you believe in. Again, it's all about policy. It is part of our civic duty as United States citizens and part of this experiment of democracy. So please go out and vote if you can and be good to one another. Especially to those that you don't have similar ideologies with, if they believe in stuff that you disagree with, let's just be chill. No need to get mad at each other. We all progress with different ideas. I mean, just look at what we did today. I think this is a fucking stupid idea. I still did it. Because people asked me to. And, you know, I think it's important to support ideas in the community. So, even though I think this is a dumb idea for a permanent mount, because it's just going to be easier to not have it permanent. Again, that's just me. I did it anyway. So, yeah. Oh, build plate marker was not detected. Well, you're a dummy. Resume printing. It's there. All right. Anyway. Good night, guys.